Hello, my name is Yogi Barot, and I'm part of Microsoft Technology Specialist Senior Solution Architect team at AWS. I have 20 plus years of experience working with different databases, especially SQL Server on premise, on cloud, and I'm helping customer how to migrate SQL Server to AWS. So today we'll talk about how to configure SQL Server on AWS at scale. So agenda for today is we'll talk about how to run SQL Server on AWS, overview of it, and we'll go through the launch wizards for SQL Server, some of the features it has to offer, including the use case and the benefits of using launch wizard. We'll also choose from launch wizard and the quick start, which one to pick based on your requirement. And we'll also go to do a demo and a workshop of the using SQL Server with Launch Wizard. So why customer move their database to AWS? For especially for SQL Server workload, right? So on AWS, we provide the different options to deploy your SQL Server to AWS. First, you can rehost your database to our EC2 instance platform in lift and shift fashion. On EC2, you have a full access to the operating system. You can run various flavors of operating system. Additionally, you have an option to leverage a license included model or BYOL models. The second option is to re-platform your database and run it on Amazon RDS for SQL Server. Here, you can select the compute performance that meets your requirement. However, the service removes the undifferentiated heavy lifting from you, taking care of operating system patching, monitoring, availability, backup of the instance, while you can focus on how your database is configured. And the last option is to refactor to a purpose-built database like MySQL or Amazon Aurora for PostgreSQL. With going to Aurora, you eliminate the cost for SQL Server licensing with the potential to run your database at 1/10 of the cost of commercial grade database. So in summary, you can run SQL on EC2 when you bring your own license. That will be your cheapest option for lift and shift migration. And if you want to move to managed service and uh, remove the undifferentiated heavy lifting, go to RDS for SQL Server. And if you want to eliminate the SQL license cost completely, you can refactor to a purpose-built database like Aurora. So why SQL Server on AWS, right? So customer has been running SQL Server on AWS for more than a decade now. AWS is 62% cheaper than the next largest cloud provider by price performance. You can it's two times faster than the next largest cloud provider. You can get the better price performance and reliability. Also, with a flexible licensing option, you can bring your own license, and you can also run SQL Server on license included instance. Um, we can simplify the deployment and experience in the migration, monitoring, and management. Also, AWS offers the broadest and the deepest capability for Windows workload. And we have a greater security and identity services than next largest cloud provider. So having said so, today we're going to cover simple and integrated operations experience, and using launch wizards, we will cover how we can simplify the experience of deployment in your migration journey. So when we migrate, we have a multiple tools that we use to migrate SQL Server to AWS, right? So when you are using migration, you can use Cloud Engineer to migrate your database, and Cloud Engineer you can also use for disaster recovery as well. So for deployment point of view, we have a service called AWS Launch Wizard. A Launch Wizard for SQL Server can help you deploy your single instance or high availability instance using Launch Wizard. For monitoring, we can have Amazon CloudWatch application insights to automatically set up and alert your monitoring. And we can have a system manager for management and troubleshooting of your SQL Server. So overall, Launch Wizards help you to integrate your SQL deployment with monitoring and the management of SQL Server. So, what is customer challenge of deploying SQL Server at large? You need to have a deep expertise to plan your SQL Server architecture in AWS. Especially, we offer a variety of instance types. So, which instance type to select for your SQL workload? What kind of storage type to select? And any opportunity to consolidate your SQL database? What kind of SQL Server version and additions are required? What to do with the licensing? Any upgrades to be done while deploying to AWS? All of this is time consuming and it can prone to errors and inconsistency. So this to avoid this challenge, we came up with a service for Launch Wizard. So what's an AWS Launch Wizard for SQL Server deployment? So basically, it used to deploy SQL Server for single node or HA deployment on EC2. It offers a guided way of sizing, configuring, deploying your AWS resources without need to manually identify and provision individual AWS resources. So how do you start it? So to start with, you basically you input your application requirement, including the performance, number of nodes, connectivity, all this basically networking, all the details on the service console. And once you launch, so then Launch Wizard will identify the right AWS resources, such as EC2 instance, EBS volume, and to deploy your application based on your input. And it automatically select the instance and storage based on the input you provided. It also provides an estimated cost of deployment and lets you modify your resources to instantly view an updated cost assessment. Once you approve your AWS resources, Launch Wizards automatically provision and configure the resources to create a fully functional production ready application. Now, the purpose of today's presentation, how to configure and deploy your SQL Server at scales. So Launch Wizard basically creates an cloud formation template that can serve as a baseline to accelerate subsequent deployments. So using this cloud formation template that you deploy for your one sample SQL Server cluster, you can take it and scale it for more of your SQL deployment. For example, I had a requirement earlier to have a customer need to create a 40 SQL Server cluster using Launch Wizard, right? So if they go suggest create the one cluster, the Launch Wizard will give them a template, and that template will follow the well architecture framework of AWS and application best practices, right? So this means the application deployed using Launch Wizard adhere to the AWS best practices and are optimized for security, reliability, and performance efficiency and cost savings. So, what are the use cases for SQL Server? If you have a single node or multi node deployment, and if you need HA with always on or SQL Server FCI with FSX deployment, Launch Wizard works to simplify your deployment. It supports dedicated host and SQL Server on EC2. It also supports license included instance, and if you want to bring your own license, it also supports BYOL model as well. It works on Windows. At the same time, it also works on Linux and Ubuntu as well. So from configuration point of view, the good thing about Launch Wizards and the unique features of Launch Wizard is it does the early input validation. So when you give your performance requirement, it does validation to see whether it's a best fit or not. And you can connect to Active Directory on premise, or you can connect to Active Directory on cloud, like managed Active Directory on AWS. And you can set up notification and monitoring with a single click using Launch Wizard. So Launch Wizards recommends the appropriate AWS resources, including EC2 instance type, EBS storage, volumes, type, and to match your application requirement and present you with a cost estimate. You have an ability to modify the recommended resource selection and get an updated cost assessment. Launch Wizard is available to you at no additional cost. You only pay for the AWS resources that are provisioned for running your solution. AWS Launch Wizard walks you through an end to end deployment experience of always on availability group using prescriptive guidance. By answering a few high level questions about the application, such as required performance characteristic, the wizard will then take care of identifying, provisioning, and configuring matching AWS resources such as Amazon EC2 instance, EBS volumes, and VPC. Based on the selection, the wizard presents you with a dynamically generated estimated cost of deployment. As you modify your resource selection, you can see an updated cost assessment to help you match your budget. And once you approve, after that, Launch Wizard provisions those resources and configure them to create a fully functional, production ready SQL Server always on deployment in just few hours. So subsequent SQL Server always on deployment become faster and easier as Launch Wizard will give you dealing with the required infrastructure on your behalf and determining the resource that match your application requirement, such as performance, memory, bandwidth, etc. You can also modify the recommended details if you wish. And if you want to bring your own license or have custom requirement for the instance, you can also select to use your custom AMI, provided they can meet certain requirement. Earlier this year, AWS Launch Wizard announced that it's going to support for SQL Server FCI with FSX deployment. So what happens sometimes you need to have a SQL Server deployment, which is shared storage, right? So shared storage for your highly available SQL Server. So AWS recently announced that Launch Wizard supports for always on failover cluster with Amazon FSX for Windows File Server as a shared storage solution. So the wizards walk you through the end-to-end deployment experience of always on failover cluster using a prescriptive guidance. Same thing as with always on, it also creates your EC2 instance, VPC. At the same time, it creates your Amazon FSX file system, right? So based on the selection you present, it dynamically generates the estimated cost, and once you approve, it creates the resources for you. Also, it gives you a cloud formation template as a baseline for repeatable and consistent application deployment. So when you start with the launch wizards, once you define your infrastructure requirement, where you can select your storage, your compute, and you have two options. So by default, you will see based on the infrastructure you have provided, it will give you a recommendation. And if you know a specific instance type that you want to go, you can pick that specific instance type as well, right? So similarly, you can also input your storage performance and capacity requirement, and Launch Wizard will recommend a throughput and FSX storage for your needs. This is very important because you want know how much your throughput requirement for FSX for your workload. But based on your IOPS and throughputs requirement of your database, the launch wizard will automatically select an appropriate throughput for FSX. Not that your FSX storage capacity is a function of your peak desired IOPS and your desired storage capacity, and therefore it may be higher than the allocated storage space selected. You may modify your inputs, and the recommended resources will get updated based on the input. So this screen just show the sample of the different estimates. Now you might have a questions that what's the same thing I can do with the quick start. So what's the difference between the launch wizard and the quick start, or how do I choose between the launch wizard and the quick start? So what we suggest that launch wizards should be your primary method for deploying SQL on EC2, unless you want to start with a quick start cloud formation template and customize for automation. The difference between the launch wizard and quick start is quick starts take care of the basic HA deployment with always on availability group and FCI with FSX. But if you need to have your deployment done on Linux, Ubuntu, then you should go with Launch Wizard. If you just need to have deployment done on single SQL Server node, then Quick Start does not support and you have to go with the Launch Wizard. If you need to have a deployment, if you need an instance type recommendation and the cost estimation, then you should go with the Launch Wizard. For auto one click SNS as notification and one click CloudWatch notification, Launch Wizard is a way to go. Another good feature of Launch Wizard is it does an early input validation and managed IAM policy. So I hope this will give you different options and the features what to choose between Launch Wizard and the Quick Start for your SQL Server deployment. Now I'm going to walk through with the workshop using AWS Launch Wizard for SQL Server. So in the demo activity, what we will cover, we'll cover the create SQL Server always on cluster using Launch Wizard. We'll connect to the EC2 instance, connect to the SQL Server Management Studio. We'll validate all the resources created part of the infrastructure, created part of the Launch Wizard deployment, and we'll also check the SQL Server always on availability group, and we'll add a database and see how it is synchronized. Same thing, we'll also create a SQL Server FCI with FSX using Launch Wizard. We'll connect to the EC2 instance, connect to the SQL Server Management Studio. We'll check the failover cluster. We'll check the FSX share. And at the same time, we'll also create a SQL Server database on FSX and validate that. Now let's do the demo for this workshop. So first is go to your AWS console in your account and you can select any region. In my demo, I have selected the US to North, US East region with North Virginia. And you can type using AWS Launch Wizard. You can search for that service. Once the services comes up, what you can do, you can click on the choose application. Here you can select SQL Server, SAP, or Active Directory application. So in our deployment, we will be using Active Directory application. You can also deploy it using Launch Wizard as well. So let's select the SQL Server deployment over here. And first of all, what it's going to do is going to create an IAM role on your behalf that lets Launch Wizard access other AWS services on your behalf. And it creates a default IAM role named Amazon EC2 role for Launch Wizard. So once you start that, you have to select the operating system. As I mentioned earlier, Launch Wizard for SQL Server is supported for Windows, Linux, Ubuntu operating system. You can pick the operating system over here. In the deployment model, you can select a single instance deployment or a highly available deployment using always on or SQL Server Failover Cluster with FCI with FSX. So let's pick the high availability deployment with always on availability group here. Let's give a name SQL always on Launch Wizard, and you can also select an SNS topic to get notification and alerts. We also have integrated Launch Wizard with the application inside. So basically when you select this, it sets up the monitoring and automated insights for this deployment using CloudWatch application insights. And by default, when the deployment fails, your resources will not be deleted by or rollback, but you can select these options if you want to delete or roll back immediately after the deployment fails. You can have first you need to choose a key pair. You can create your new key pair by going here and give the new key pair name. And so create key pair over here. What kind of key pair it is and what format it is, right, for PuTTY or OpenSSH. And or you can select an existing key pair. So in my case, I do have a existing key pair, which is I'm going to select over here. So let's choose an existing key pair over here. In the tenancy model, you can run the Launch Wizard on shared tenants, or you can run it on dedicated host as well. Let's pick the shared tenancy over here in our case. Now it's going to ask about the VPC. So if you have an existing VPC setup with a public subnet and a private subnet, you can select that existing VPC. But the condition is you must need to have one public subnet and at least two private subnet for your deployment. And the private subnet must have outbound connectivity to the internet and other AWS services. If you don't have the VPC setup, you can choose this option to create the new VPC, and it's going to create your new VPC for your deployment. So since I have the VPC created already, I'm going to select this option. I'm going to pick my VPC from the list over here. Now this option is for remote desktop gateway preferences. So basically, if you want to set up a remote desktop gateway for RDP access, which I want to set up, so let me put it over here, and I want to have my IP being accessible. And public subnet, I can select a public subnet. If not, I can just create the new public subnet over here as well. Now let's select our availability zone. Here I have a US East 1A, and I'm going to choose a private subnet in one as US East 1A. And for the secondary availability zone, I'm going to pick US East 1B, and I will select the private subnet in US East 1B. This is important. You need to confirm that you have a public subnet that has been properly set up and each of the selected private subnet has outbound connectivity enabled. Since I have it set up, I'm going to just click on OK for that. Now, next is for the Active Directory. As I mentioned earlier, if you don't have an Active Directory setup, you can also use a Launch Wizard to create an Active Directory and use it over here. Or you can create manually and connect to the new AWS managed AD over here. In my case, I have an existing AD which I can connect. So let me just pick an existing AD. Here I have two options. I can connect to on-premise Active Directory, or I can connect to AWS Managed Active Directory. Let me pick the AWS Managed Activity here. I'm just going to use an admin domain username and the password, which I have it here. I have to give a DNS address and the domain name from the directory. So let's go to my directory services tab over here, and this is my directory name. So I can select the directory name from here, enter the DNS name, and I have to select the DNS address. So let's select this managed AD and go into the details, network and security. Here you go. I can see those DNS address. Let me copy them and I can use those IP addresses over here. Make sure there is no space in the front, in the back. Yeah, no, it looks good now. So basically what we are trying to say, the SQL Server deployment, the SQL EC2 instance will be joined to this Active Directory. Now we have to select a service account for SQL Server service. So we can use an existing service account or we can create the new service account over here. I do have an existing service account, SQL admin, so I'm going to just use that and give the password for that account. Now we have to select the AMI. So here we have two options. Remember we mentioned we can bring your own license using custom AMI. So if you have a custom AMI, you can bring your own SQL Server license through custom AMI, or we can also use a license included AMI. In that case, AWS provides a license included AMI with Windows and SQL Server installed on it. So I'm going to choose license included AMI, and I can have AMI picked from this list. This has different version of Windows, different version of SQL Server. I'm gonna go with the latest SQL Server here with the SQL Standard Edition. Obviously, I don't need an enterprise feature here for this demo, so I'm gonna just pick the Standard Edition. And once you select that, this is an optional settings, but I highly encourage to input it so that you have your names given for your deployment. So basically here we can have your primary SQL Server name, SQL primary. You can have a secondary SQL Server name, SQL secondary. And you can have a witness as well. If you want to have a file share quorum witness node, you can have an additional node for that. Database name, you can select a database name. Um, Live system, for example, this is a database. It will be created empty when you create your deployment. It won't have any object, but it will make it ready for you. You can also select an always on ability group name. So in our case, let's just pick a SQL AG, and then you can also select a listener name, SQL AG listener, and you can also select cluster name. So you can give any name. These are all the things are optional, but I just like to have a name which is familiar to me rather than just generated random name by the wizard, right? So once you have given this information, then you move to the next step over here. This is important thing. Basically, remember we mentioned about it does an input validation and suggest an instance type for you. So this is a place where you put your requirement. So SQL Server, so basically we can go two ways. We can go based on the infrastructure. You can specify exactly how much of core and how much of memory and network performance, storage performance you need. Based on that, it will select recommended instance type for you. Or if you know that I'm going to go for R5D 4x large. So if you know your instance type already, you can just go and pick from this list, right? So if you know that I'm going to go R5B, for X large, for example, in this case, then you can select that and say you can select the different volume type as well. So now let's give an example of creating based on our infrastructure need, because you might not necessarily don't know what instance type you want to go, right? That's all the purpose of this launch wizard to help you size the right correct environment based on your usage. So at least we know how much of CPU we have it, right? So for example, if you have 4 core and SQL Server is more on memory heavy, not on CPU heavy. So you don't need more CPUs to be allocated, but I need more memory over here. So I'm going to pick 16 gig of memory list. Network performance is fine up to 10 gig. Storage performance here, I can select the SSD or HDD. Let's select the SSD for faster performance for SQL Server storage. And throughput here, we can say up to 250 megabytes per second. Or if you need more throughput, you can see here the instance type changes based on it. As soon as I specified more throughput, the volume type become IO1. Um, let's just pick the 250 megabytes per second. So volume type is GP2. M6I X large is an instance type that's been recommended for me for this deployment. Drive letters and the volume size. As you can see here, we have by default SQL Server root drive where you install your SQL Server logs file for storing your SQL Server logs, and data directory for storing your data, and backup directory for storing your backups. Volume size, you can select a different volume size. I don't need that high volume for the demo. Let's me just pick 100 gig, for example, and you can choose your volume size. Based on that, it will show in your estimates how much it will cost. So once you select your drive letters and the volumes here, you can also change your letters to a different letter number if you want. So once we finish that, you can also tag this deployment. So let's tag is SQL always on Launch Wizard. So we have it. We know how to identify our resources. And at the end, it's going to give you here the estimates, the estimated on-demand cost to deploy these resources, right? So as I mentioned earlier, Launch Wizard is free. There is no additional cost for Launch Wizard. But when you select the resources, it just costs you for the resources. So if I have selected Witness Node here, that's an additional EC2 instance. It's going to cost me 135 per month. I don't have to select the so for the compute, so there are two component of the pricing. One is a compute, another is a storage. So for the compute piece here, based on the instance type we selected, it's recommended. We have a two compute instance with M6I X large will cost us $1,232. And for the volume, 400 gig of GP2 volume, it will cost us $40, right? So this is our total approximate estimated monthly cost for this deployment. And we can go next. And once we go next, basically, it's going to ask us to, yeah, so I just, let's just remove this right now. So once we go next, tag value could not be empty. Okay, I see. I have to put some value. So key is an name, value is a SQL always on. Once I have that, let me click on next here. Yeah, the review and deploy. You can see the summary screen over here, the application name, keypad name, domain name, VPC ID, availability zones, subnets we have selected, what kind of AMI we have selected, the instance type, volume type, database name, primary, secondary node, listener name. And we acknowledge that it's going to cost us $1,400 for um, this deployment, this resources. And after that, we can click on the deploy button over here, right? So once we click on the deploy button, it's going to take approximately 2 hours, few hours. Basically, it's around 2 hours to finish your deployment. So looking at the time constraint, I'm going to kind of assume like you click on deploy and wait for deployment to finish, and but I can show you the existing one which I have already created. So let me just cancel this deployment. While it's happening, what I can do, or actually I can click, yeah, I can show you the existing deployments that I have for MS SQL Server. So see here, I have a SQL 2 deployment, one for always on and another for FCI. We will go with both of them. So now let's look at the SQL always on Launch Wizard deployment. It's using exactly the same settings that we specified. So once what it's going to do, it will create a series of events. First of all, it will create a stack. And it will create series of event in the stack, and then it will execute the CloudFormation template for you. Right, so first event is going to validation. It's going to validate the input specification, make sure everything you specified is valid for the SQL Server deployment. Then it will create the resource group, creates a resource group with all application resources, create infrastructure for the application deployment, and create the remote desktop gateway stack. And then after that, it creates the SQL Server stack. Right. So once we have all this completed, then we can see the result. Something looks like this. Here you can go to the configuration summary, and you can also check the details of the configuration. So you can check the VPC, availability zones, subnets, public subnet name, private subnet names, which domain username is used, Active Directory DNS name, SQL Server always on listener name, database name, availability group name, SQL username, primary node, secondary node, all these details basically, and the instance type, and the database replica instance type, and the volume type, and the SQL drive letters. So once you have all these details, now let me show you how you can connect to a EC2 instance for this Launch Wizard. So you can select this SQL Always On Launch Wizard and go to Accents over here, and here you have few options. You can view resource group with SSM. You can view CloudWatch application logs for this Launch Wizard. You can view the CloudFormation template. So let's check the CloudFormation templates for this one. It will show you exactly which template it was used. So basically it used this templates. First it creates the Windows Failover Cluster and always on ability group nodes, right? And this templates creates the installed into existing VPC with Active Directory domain. It creates the auto scaling for RD gateway instance and public subnet. And this template, it deploys the Windows Failover Cluster and SQL Server always on ability group nodes, right? So this template actually creates the EC2 Windows instance and related resources. So these are the these are the templates that's been used by this deployment, right? We can also go back here in the accents and check the, so what advantage of this template over here is basically if you have a large scale deployment, if you want to scale your deployment, you got the the template created based on your input and based on the best practices. You don't need to worry about security, how to set up this in AWS cloud, different resources. create the VPC subnets, making them secure, create the remote desktop gateway, Active Directory. Everything can be created using this Launch Wizard template. And once you have this cloud formation template ready, created by Launch Wizard, you can use the similar one for your future cluster deployment. So basically, kind of a cookie cutting thing. Once you have it ready, you can use it to scale your SQL Server deployment using the same template. Now let's look at the here manage resources on EC2 console. Select the deployments, click on the manage resources. It's gonna open the EC2 management console over here. In the console, as you can see, we have a SQL primary and secondary node. What I'm gonna do, I'm gonna have this remote desktop gateway filter added as well, so that we can select the SQL always on remote desktop gateway, right, server. So this server will allow us to RDP, right? So now let's select this server. What's the difference between this server? As you can see, it has an public DNS and then public IP address, because this is what I will be using to make a connection. So let's click on connect and download the RDP client, download the remote desktop file for it. And here is the public DNS and the username. Now let's get the password. Remember, we created the file for the key pair. So the key pair associated with this instance is SQL POC. I can browse through the SQL POC key pair, select that, and it's gonna decrypt the password, and it can give me the password, which I can copy to make a connection to it, right? So that's all about RDP. So let's click cancel over here and go to that SQL Server RDP file that I have downloaded, and let's make a connection using that. So here is an SQL Server RDP file, and what we have to do is we need to make sure that the SQL Server security group that I'm using has an access to my machine, right? So I just want to, since I confirmed it, I just want to double check and show over here. So basically go to the Launch Wizard security group that's been created. Make sure my inbound IP address for RDP has an access. My IP address has an access. Since my IP was changed, I couldn't connect. So now I have added the IP address. Let's go back and try to RDP over here. Um, Okay, so it's gonna prompt me for my credential, right? So I'm gonna select over here. So there is an administrator account and the password which I copied. I can use that to connect, or I can connect using an domain admin password. I'm just gonna select the domain admin password over here to connect, so that I can see my SQL Server resources. Let's select the remote desktop connection. Okay, and it's gonna bring up the SQL Server over here, remote desktop server over here. So now you are connected. What you want to check here? This is if you look at the Windows Explorer, this is just an this okay. So I'm connecting to RDP. So let me disconnect here. So as you let's see the Windows Explorer over here, and you can just see this PC with just a C drive, right? So now we need to make a connection. This is a remote desktop computer, and we need to make a connection to our SQL Server database. So let's go back to EC2 instance running, and here we can search for SQL always on, and it's going to bring up all the resources for always on. So this is the remote desktop gateway where we have connected. After we make connections, let's check here the primary server and secondary server. As you can see, the primary server, there is no public IP address and there is no public DNS. It's there in a private subnet, right? So you can't you can't RDP to it directly. So what you have to do for that case, you need to use this remote desktop gateway, and we can RDP to it. So let's just select the details of this server, select the private IP address of this server, and use our existing RDP remote desktop connections in here, and copy the paste IP address and connect using an obtained admin username and the password. Since we select an domain joined EC2 instance, it's already taken care. You have the launch wizard has created the stuff for you. So now let's check first thing, let's check the Windows Explorer and check the disk that you have configured. This is your C drive, D drive, where your SQL Server log files will be created. You can see the logs files are over there. The live system database is created. You can see your SQL Server data files on E drives, and you can see your SQL Server backups on F drive, right? So that's just about the basic Windows installation. First thing, what you check with the SQL Server always on to make sure that the failover cluster is set up properly. So let me show you the demo of failover cluster. So let's select this failover cluster manager. You can see the SQL Server. Since we did not specify the name of the failover cluster, it just created a new cluster name. And you can see here the roles. This is an always on ability group cluster name that we gave. Library lib ag, it's up and running. You can see the nodes. It has automatically created the SQL primary and secondary nodes. You can check the details of these nodes, right? So looks like right now one of them is primary up and running. Yeah, both of them are up and running, and one of them is active. um, Once you have that, now let's select check the SQL Server services if it's installed properly. So I can go through the SQL configuration manager over here. And once you go to the configuration manager, you can click on the SQL services and check the SQL Server is installed, up and running. Important thing, check it's using an SQL admin account that we have given during the setup. So all the services on both the nodes will be running using the same account. Now main thing is connect to the SQL Management Studio. So let's select the Management Studio over. Okay, so now let's connect to the SQL Management Studio. You can connect to the database engine using SQL Primary. Let's see primary over here. And you can also connect to a SQL Secondary. Let's see secondary over here. Yeah, and you can see let's refresh this. Yeah, you can see the both database are synchronized. You can see a always on availability group over here with a uh, AG name lib AG, and then we have a database added to the library system. But this database is empty, so it's not going to be of use. So if you have a new application, you can create your objects in this database. Okay, this is a primary. So it's okay, you can select the object in this database. You can create your tables and views in this database. Or if you said, oh, I do have an existing copy of the backup, which I want to add to the always on ability group over here. So what you can do in that case, you can just remove the database from the ability group over here. It's gonna remove it, and you can see over here it won't be synchronized anymore. And you can delete this database. I don't need this database anymore. Let's delete this database, refresh, delete it from this node as well. And now what I'm going to do is I will make sure I have a backup of AdventureWorks database, so I'm going to restore it over here. So let's go restore the database. So what we can do, we can also connect using a listener here. It will always make connect to the active primary database, right? So let's check over here. So listener is connect to active primary database. So now next step is go and add an go to the listener and we can add an database over here. So let's add an database over here. This is your user data. The prerequisite is full back recovery mode is required. We need to make sure the database has a full recovery mode. So let's go and update the database recovery options over here. Change to full recovery mode. And after that, it's not going to allow to add as well because you need to do a full backup after full recovery mode, right? So basically, let's go here and take a backup of this database, primary database. Let's just remove, just add it onto our backup directory over here, adventure bugs 2019.bak. Once I have the backup file, let's click OK, and it's successful. Now, when you go to the databases, you can see it meets the prerequisition, which the number one prereq is it has to have a full recovery mode and you need a full backup. So now I can select this database and I can connect to the secondary server name. Just click on connect. Um, and next, I can select the different options of synchronization preference, automatic seeding, full backup, and lock backup. Just join in case if you have a backup already restored on the secondary, and you can also skip initial data synchronization. Let's just do an automatic seeding over here. And as you can see, it passed the check, and let's finish this. So it successfully added the database to always on availability group. Now let's verify that on secondary. So let's refresh the secondary over here. You can see it's synchronized. Let's refresh the group here. You can see this is secondary. Let's refresh the database over here on primary. You can see it's synchronized, right? So now you have successfully added your SQL Server database, which has your data, tables and everything to always on availability group using an infrastructure which was already set up using a SQL Server Launch Wizard. Okay, all right. So now let's go to the second deployment options over here, right? So we looked at the launch wizard using a failover with a always on. There is another deployment that you can do using a failover cluster with FCI with FSX. Let's quickly cover that. So you can click next over here and select the Windows operating system, select always on failover cluster instance. We can give a SQL launch, FCI launch wizard, the name, and same thing here. We can enable CloudWatch monitoring or we can enable rollback on failed deployment. Let's select the same key pair. Let's select the shared hardware VPC. Select your existing VPC, set up the remote desktop gateway, select the public subnet. Let's select the private subnet that I have and select the private subnet in secondary availability zone. I confirm that we have a setup. Select connect to an existing active directory, managed AD. Let's pick the same managed AD, same account to be consistent. And it has since we already provide the DNS name, it has a DNS address selected, so we don't need to add it again. Domain user security group, this is optional. We don't need to select this. SQL Server service account, let's pick the same SQL admin service account. And license included instance, you can also bring your own AMI. Here, let me choose the same SQL Windows Server with a SQL Standard AMI. Additional configuration options, you can give here the SQL Primary Launch Wizard, FCI, SQL Secondary, FCI, and you can give your SQL FCI virtual network name and then SQL FCI cluster, right? Once you give all this detail, let's pick the next missing field. Let's see what is missing over here. Because I have this name already. Okay. So let's just click next. And here, same as last time, we can pick our SQL Server resources, 16 gig. Important thing here with FCI, with FSX, you can select your average and peak IOPS. What will be your input and output requirement for your workload? Based on that, it will create and recommended FSX throughput for you. So for example, if I selected 4000, it's going to select 64 megabits per throughputs and 5 terabyte of storage, right? If you select the higher pick higher average IOPS and higher peak IOPS is going to bump up, increase the throughput, right? So let's try that. As you can see, it changed the throughput to 1 gig, right? So we don't need that high IOPS, but basically based on your SQL Server requirement, you can select average IOPS and the peak IOPS, and based on that, Launch Wizard will recommend an FSX throughput capacity for you. So let's pick this one, desired storage. I'm just using 1 TB over here. And then drive letters and volume size, you can select your drive letters here as well. Um, because since you are not using your SQL Server, since you are installing your SQL Server on FSX, you don't have a data log and backup drive separate over here. It's all part of the FSX. And you can see estimated cost of deployment, which is your instance costs, just like last time, your instance compute cost, and you have your storage cost. Storage cost include your FSX cost, store your backup for that 1 TB that you have selected, and throughput cost, right? So total, it's going to cost $3,000 for this deployment, and then you can click next, verify, and submit the deployment. Let's see the deployment which I have already created, and we can walk through the details same way. So SQL FCI, let's check the here when you select the deployment events, you can see the configuration summary, and you can check the availability zone details, key pair name, all these things, domain name, and primary node, secondary node name, and SQL Server virtual name, and all these things. And here important is your instance type and the throughput capacity, what I have selected for this deployment. So once I verify and everything is completed using this Launch Wizard, it's going to again take 2 hours for your time, and from the time you start and it deploys successfully. After that, you can come here and go to their Accents Manage Resources on EC2 instance. It's going to bring up the EC2 console where you can see your SQL Server instance, primary and secondary instance listed over here. Okay, so I have it stopped right now. So what I'm going to do, I'm going to just start the instance so that we can connect to it, right? So let me just start the instance, both primary and secondary as well. At the same time, let me also check for the remote desktop gateway and connect that into that instance as well. So let's remove this filter and check for the remote desktop gateway. It's up and running, so that's fine. I can select the public IP address for this and make an RDP connection to it. Now let's connect to a remote gateway server for FCI. Select yes. It's going to open the server connection. Now, once we are connected again, let's go with the remote desktop connection here and add our EC2 instance address. So let's go to EC2 instances and search for, this is our FCI primary node, get the address for this node, and then we can copy here and make a connection to it. Make sure we give our same username and the password to make a connection. So what are we doing is basically we have set up an SQL Server FCI with FSX using Launch Wizard, and now we are verifying the setup. So first of all, let's go to the drive over here. As we checked earlier, there's only C drive because the database and everything is installed on FSX share. So first thing we'll do here is verify the failover cluster. So let's check our failover cluster manager and see if SQL Server is installed properly, the role is configured, and we have nodes are set up. So let's check the role over here. As you can see, SQL Server role is considered, and there is two node over here, primary and the secondary node. So it seems to look fine. Now let's check the SQL configuration manager here and check the SQL Server services to see. Right now, this is a primary server. Looks like it's up and running on secondary because I did the failover. So this one, the service is not running as a nature of SQL failover cluster, but we can check the secondary server as well. So let me just remote desktop to a secondary server as well. Let's go here. Desktop connection, and let's find out what server, secondary server IP address, which is this one, RDPT over there. So now we are connected to secondary server, and let's check the SQL Server services over here. It should be SQL configuration manager here, and let's check the SQL services over here. Yeah, as you can see, it's up and running. So this is our active database right now, and other one was our passive database. So if you have not done the failover, you will just see the primary one as an active database, and then this one is as a secondary database. So now, once we verified our SQL Server, what next we want to check is our failover cluster instance. So let's see if we can make a connection using Management Studio and connect to our SQL Server database. I can make a connection using both primary and secondary node. We can check it from both the nodes. While this is coming up, let's just check and verify our SQL Server cluster name over here in the configuration. Let's check the primary node. Yeah, this one is our virtual network name, SQL FCI. Okay, and still coming up here. Connect to the primary server. Management Studio. Oh, actually, I'm searching on the. Okay, here you go. SQL Management Studio, and what I want to show here is if we can connect to SQL Server, and at the same time we also want to see where is our data and log files being located. So okay, this is name of our SQL FCI is the name of our cluster. Let's see if I make a connection to it. I can see it's connected here to the primary node, and I can see a database, default database with no object created here as well. As like the previous demo, we can also attach the SQL Server database over here, and we can check the data over here. There is no always on enabled over here because it's an FCI cluster. So what else you want to see here is basically, let's see if I can make a connection to SQL Server account over here. Since this is a primary server, I just see a SQL FCI database engine. But what if I put the SQL primary, the node name, what was the node name over here, SQL FCI primary. Just want to show it's an active passive implementation. So you won't be able to make a connection because this is not an active node, so it's gonna time out. But if you connect to the SQL FCI secondary, you will see an connection attempt over there. Also, I want to search for the FSX over here. So let's look at the FSX service over here, and let's check the share name. As you can see, this share name is created used by Launch Wizard, and this is where your data file exists. We can check the details of the share name, the throughput, the capacity, the storage type. We can easily update it over here if you want to make an update. Let's copy the DNS name and then connect to that using a SQL Server share. So as you can see, I cannot connect to primary over here, but if I select SQL FCI secondary, I should be able to make a connection. Yes, here you go. It's connected because this is our primary node at this moment. Now let's check the data files. Where are my data files? So you can basically simply check the share using this share name, and you can see MS SQL folder here. Here your database files, and here is your log files. And your SQL Server is installed in this directory, right? So basically, this same share you can access. This is connected from secondary node. Now let's connect from the primary node, which is this. I can connect to the SQL FCI from primary node as well, and it seems to work fine. And I can also connect to the share from primary node, and both of them points to the same database. Now I want to show an impact of a SQL Server failover cluster with adding of a log file. So I have a database backup over here. Let's see, this is I'm connected from primary database, and I'm going to add a restore database here using these files that I have got. And I will just want to show you how fast it is to perform a restore. So when we restore, or let me just add a database over here just to be safe. Just when I add a new database over here, test FCI, and let's check it. Database is added, and let's check on the secondary server. This is secondary server. Look at the MS SQL data. You can see the file there. Because at the underneath it's pointing to the same share, the data is there instantaneously on the both the servers at the same time. And if you refresh the database over here, I didn't add it on secondary, but you will see database added to secondary. You will see database added over here as well. The same way you can do with the restore of your database as well, and you can see both of them are part of the SQL FCI cluster. So overall, that shows our demonstration of using a SQL Server Launch Wizard with FCI with FSX, where you can see the FSX shares are created, a EC2 instance are created, SQL Server failover cluster is created and set up to have an active passive deployment. That concludes our demo for today, and thank you for watching. Let me know if you have any additional questions for this. You can follow up. So now what's the call to action? If you want to learn more about the Launch Wizard, we have a link to documentation and the web page. We also have an additional step-by-step guidance on and the blogs written how to accelerate your SQL Server always on deployment using Launch Wizard, and how to accelerate your SQL Server always on FCI with FSX deployment with Launch Wizard. Um, Thank you for watching this workshop, and please contact us if you have any further questions. Thank you.